Hey, this video will show you some hacks so you can master the half-life problems. So recall that we do have some task verbs: identify, describe, explain, justify, make a claim, and propose a solution. Today we're going to be talking about calculate. So you've probably seen this poster. This poster is color-coded, and there is a formula you can plug in. You will have to remember that. Or you can follow this graphical way of doing it, which is what I prefer to do. Now, I couldn't tell you how to do this because I don't have one of those fancy calculators. I also didn't do quite well in pre-calc, and I never took calculus, but you don't need to. I'll show you some easy ways of doing this. So here's an example. In 2020, a 25-gram sample of radioactive waste remained from an original 200-gram sample from 1960. So calculate the half-life of the original sample. Now I have these four different parameters or things I'm going to be determining. I got the initial value, the final value, the time elapsed, and the half-life. We're going to go through one of each of these examples, and you will be asked to do one of these things on a half-life question. So first, we already can identify we have a 25-gram sample. We also, that was our final value. We have an initial 200-gram sample. We know that the time elapsed went from 1960 to 2020. So that's a total of 60 years, and I need to determine the half-life. So let's set this up. I'm going to start off with my initial value, 200 grams, and then I half-life is 150, and then my final value of 25 grams. I know that this entire process took 60 years. So I have 1, 2, 3 half-lives. 3x equals 60. X is 20 years. Next example. A radioactive sample with an original mass of 40 grams now has a mass of 2.5 grams. If the half-life of the sample is 8 days, calculate the number of days it took to decompose. Let's identify our components. We have an initial value of 40 grams, final value of 2.5 grams. The half-life is 8 days, and I need to figure out the time that has elapsed. So I'm going to set this up. I'm starting with 40, then I'm going to divide it by half. 20, 10, 5, 2.5. So right there, I know that I have 1, 2, 3, 4 half-lives. Each one of them is worth 8 days. So 8 times 4 equals X. X is 32 days. Next question. After 16 years, 1/256th of a radioactive sample has been discovered in a laboratory. If the original mass of the sample was 7,680 grams, calculate the mass of the sample that remains. So I'm going to identify, I got 16 years that's elapsed. I don't have a half-life, but I have the number of half-lives I can determine, 1/256th. I know that my original value was 7,680, and I need to figure out my final value. So this one, we're going to start. We know that the whole thing took 16 years. We're starting with 7,680. We divide it by half, so this is 1/1. This is where the half-life will come in. I'm just going to basically go down until I get to 1/256th. So I'm going to show you both of these at the same time. 1/4, then I got 1/8, then I got 1/16, then I got 1/32. You see how these numbers are getting smaller as well? These numbers are doubling, these are halving. 1/64th, 1/128th, and then 1/256th. That value is X. So I went, 240, 120 to 60. X is 30 grams remaining. Another one. After 4,800 years, a 15-gram sample remains, which is 1/16th of the original mass. So calculate the original mass of the sample. So I have here 4,800 years has elapsed. My final value is 15 grams of that sample. I know that I have the number of half-lives I can determine from this 1/16th, and I need to figure out the original mass of this sample. So this one, the whole thing took 4,800 years. So I don't actually have the original value, so I can't start with that. I'm going to have to work my way around it. So I start with 1 over 1, then I go 1/2, 1/4, 1/8, and then 1/16, which is where I want to be. And I know that that mass is 15 grams. Now I have to go in reverse and I have to start doubling. So I go 15, 30, 60, 120, and X. X is equal to 240 grams. I just gave you 4 different ways of solving half-life problems. I hope that this video was informative. I thank you for your attention, and I will see you soon.